We'll move on to the concept, children. The next one is potential difference. Okay, I told you that current flows. So there is something should be there not to flow. Who makes them to flow? Can it flow like that itself? Yes, no. It needs something to make the electrons to move, no? Yes or no? So for example, what happens, I have taken an overhead tank. So what happens when you open the tap, what happens? The water falls like that. So what is that energy? Potential energy, right? So then it converts into kinetic energy, then it falls like that, right? But such gravities and all do not work in electric current. Did you understand? So, but something must be there to make the electron to move. That it's nothing but again protons only. So that difference, what we call potential difference or electric potential or electric potential. Or this can be also told as voltage. We will say voltage, very important thing. Okay, so voltage or electric potential. Okay, so how does the electrons move? So for that, let us go to the basic definition of potential difference, children. So what is potential difference? The work done on a unit charge. The work done on a unit charge to move from one point to another. So work done on a unit charge. Unit means we don't know, a certain charge. So we are going to do a work on the charge. Understand? Charge means what, children? Previously I told you, charge means what? Electrons. So I am going to do a work on the electrons. I am going to pull the electrons. Yes or no? So there must be some, so electrons, how the electrons will be attracted? Because when the hole is present, when positively charged atom is present, then only the electrons is being attracted. Yes or no? So for example, I have taken a cell. So again, everyday cell I have taken. So here we have a two terminals. This is called positive end and this is called negative end. And this is bulb. Did you understand? Okay, so now what happens? So imagine that I got 100 protons here. Okay, here I got for 100 protons, and here I got 100 electrons here. Okay, 100 protons and 100 electrons. Okay, so let us mark here AB. So let us mark AB. AB is the distance. So you just say that 10 meter. So did you understand? So as soon as I connect, these protons and all, they will pull the electrons. They will attract the electrons towards it. Did you understand? So imagine that. So how AB is 10 meter. It is taking 10 seconds to just pass from B to A. So which means this is called potential difference, children, because we are keeping the proton here and here the electron here. So more number of protons are there and a certain number of electrons are there. This is called potential difference. When you maintain a potential difference, when you connect a wire to this, what happens? Protons will pull the electrons towards it. Did you understand? So when it pulls the electrons, so that means the proton is working on the charge. Did you understand? Proton is working on the charge to pull. The work done on the proton to pull the electrons. That is called potential difference or electric potential or voltage. Now what is being happening? 100 electrons are being pulled by the 100 protons. It is going to pull the electrons. So this is called a potential difference. Okay. So now what happens? B to A. It is taking 10 seconds to go from B to A. Okay. Let us mark another one. So let us mark here C. So let us mark the distance between B to C is 1 meter. Did you understand? B to C is 1 meter is there, the distance, and B to A is how much is there? 10 meter. So, and if it is taking 10 meter to pass 10 seconds, then how much time it takes from C to B of 1 meter to pass? Yes, 1 seconds. Did you understand? So that is what I am telling. What is potential difference? The work done on a unit charge to move from one point to another point. We do not specify the which points. That can be any points can be. That can be between C to B, or that can be B to A, or you take it in any point across the two. You will get the same amount of voltage. Did you understand what I am telling? So, if it is taking 1 second for 1 meter, obviously if this distance is 2 meter means 2 seconds. If distance 3 meter means 3 seconds. So, you keep anywhere in between. So, that will give you the potential difference. The work done on a unit charge to move from one point to another, any point you take. Did you understand? So, this is called potential difference or voltage. So now what happens? The electron will flow through the bulb, then the bulb glows. Okay. So now what happens? Now what I will do? Imagine what I will do. 100 proton were there before. Now I will increase to 200 protons. Okay. So number of protons are being increased. So now, can you tell me, will it take, if 200 proton is there means, so will the force will be more or will the force will be less? It will be more only, obviously, right? Why? Number of protons are more. Now, the pulling force will be more. So, when the pulling force is more, instead of 10 seconds, it will take just 5 seconds to just move across the, bulb. So now what do we say? Before a potential difference 100 protons were there. Now how many are there? 200. Now we will say that potential difference is more. Did you understand? Voltage is more. So now what happens? It was taking 1 second. Now it just takes 0.5 seconds. Now this is called potential difference. The work done on a unit charge to move from one point to another. And we have potential difference is equals to work by charge. Charge by work. Okay. So potential difference is equals to charge by. We are working on a charge. So charge by work. Did you understand? So, V is equals to W by Q. Work by charge. We are doing a work on that. Work by charge. Okay. The V is equals to W by Q. V is equals to, always remember the formula. V is equals to W by Q. So, what is potential difference? Is ratio of work by charge. How much work you are going to do on a particular charge, on a certain charge, that coulomb. Did you understand? So, now SI unit, if you are talking about work, SI unit is joule, and coulomb SI unit is C. Coulomb charge SI unit is C. So, we say that, when do we say define the unit of potential difference? Unit of potential difference means 1 volt. Did you understand? So 1 volt is equals to 1 J of work is done on 1 coulomb of charge. Or you know that 1 coulomb means how much? 6 into 10 to the power of 18 electrons. So 1 joule of work you are doing on 6 into 10 power 18 electrons. We say that 1 volt of potential difference. So if I increase the number of work is increased, charge is same. So what is that? 2 volt. When do we define 2 volt? When 2 J of work is done on, 2 joule of work is done on 1 coulomb of charge. Did you understand? Any doubts? Okay. So this is about, potential difference. The work done on a unit charge to move from one point to another point. Okay, so now let us, joule per coulomb, or we also say that the SI unit is volt. So there ampere was there, and here SI unit is volt or V. Okay, so this is about the potential difference, the work done on a unit charge to move from one point to another. Okay, now let us discuss about voltmeter. As ammeter, we discuss about voltmeter also. Okay, what is a voltmeter, children? You know already ammeter, right? So the device which is used to measure electric current. So here what do we say? The device which is used to measure, the device which is used to measure potential difference. The device which is used to measure a potential difference is called a voltmeter. So how do we connect a voltmeter and how do we represent voltmeter? Voltmeter is represented like this. Okay, so this is plus terminal, minus terminal. How do we connect? Means we connect it in parallel connection. Okay, parallel connection. So parallel connection. So why do we connect? Why we need to connect parallel connection? I have already told you we are taking across B and C. We are taking across C and B because to measure the potential difference across the two ends of the conductor. Did you understand? So now the current will flow through this. It will not flow, but across it how much voltage is there? This kind of connection we call it as parallel connection. Okay, so why do we connect in parallel connection? Because to measure the potential difference across the two ends of the conductor, or a bulb, or whichever you can write. Okay, did you understand? Any doubts regarding this? Okay, so this is about a potential difference. And V is equals to W by Q, like how we changed the same formula, we can just change it as V into Q is W. V into Q equals W. Suppose I want to find Q, then Q keep it here only. So V is equals to W by V. W by V. We can just do like that. Did you understand? Any doubts related to this? So whichever the doubts you have, please put me in a comment box so that I can able to solve for you. Okay, so next, when doing some problems and all, we will get to know some prefixes which we are going to use, so which are very important. So what is that prefixes? The first prefixes we call micro, and it is symbolized as M. Okay, suppose for example milliampere. So you have to symbol like this. So what do you mean by milli? Milli means 10 power minus 3 ampere. So these are the prefixes. You know what do you mean by prefixes? The words which are used in front of a word. For example, irregular. Ir is a prefix. Did you understand? Like that, in physics also we are going to represent some units in some form of prefixes. In that, the first one is micro, milliampere. This is milli. This is milliampere. Milli means M. Next is micro. Micro, it is represented like this, like a U. You have written, two sides. So mu milliampere. Microampere. So 10 power minus 6. Micro means 10 power minus 6. And we have another one prefixes which we are using is kilo, and it is K. So K ampere. K means 10 power plus 3. 10 power plus 3 ampere. And mega, M-E-G-A, mega, capital M. So mega ampere. Mega ampere means 10 power 6 ampere. These are the 4 prefixes. You have to always keep it in your mind. In 10th standard, usually which one or the other problems we are going to, so you will see in any of the problem. Micro, milli, mega, kilo. Giga means 10 power 9, that and all not required. So these are the very 4 which we are going to use. For example, micro joule, if they give, you have to just use that 10 power minus 6 J. like that. Did you understand? And the next topic, the next one, we are going to discuss about that. Okay, next is circuit diagrams. Okay, so suppose ammeter is like this. Okay, so voltmeter is like this, and bulb is like this. Okay, these are all, whenever we are doing an experiments and all, we cannot put it like that itself. Understand? I cannot draw a big bulbs and all, and ammeter diagrams and all, I cannot draw like this. But these are all these things, these electrical components and all, what I will use is I will give a certain symbol for that. Okay, that means they are the, we have to assume that if I say that A means, that means it is understood that it is ammeter. Understand? If I just substitute V means that is understood that it is voltmeter. Like that, if I substitute G means galvanometer. It is also same kind of ammeter and voltmeter. Okay, so galvanometer is used to detect electrical current in a circuit. So all these and all, whenever I write it on, I want them on a paperwork. Okay, I want to write it on the board. So I want to represent them in a symbolic manner. So I am going to draw them as that diagrams, we call it as circuit diagrams. Okay, a graphical representation of a graphical representation of an electrical circuit. A graphical representation of an electrical circuit. The graphical representation of an electrical circuit using electrical symbols. Okay, using electrical symbols is called circuit diagram, children. Did you understand? So some of the examples I will give you here: components and electric circuit diagram. Circuit diagram. Okay, so which are the components that we are using? Suppose for example bulb. So bulb, if I want to use means I will just represent like this. Okay, ammeter. Ammeter means A. We will represent like this. And voltmeter. Voltmeter. We will represent like this. Okay, and if you want switch. So switch is being represented like this. We can represent like this, or we will also represent like this. Okay, so this means the switch is closed. If I erase, that means switch means open. If this means switch is open, if I just close, if I just put a 2 dot and close means switch is closed. Okay, so galvanometer. So we represent it as G. Okay, so some more components they are given here. You can just see all these components. It is there in the textbook. And a resistor. Resistor is being drawn like this. Resistor. And variable resistors can be drawn like this. We will give an arrow mark like this. And one more main important is battery. Battery means we will represent like this. Did you understand? So this means longer one always be represented as a plus, and the shorter one always be a minus. Okay, and battery, suppose battery or a cell. Okay, battery or a cell, both are same. Okay, suppose if it contains a multiple cell, more than one cell, then how do you represent like this? One is positive, another terminal is negative, and negative terminal is connected to positive. So here you see positive, and here again it is connected to negative. Did you understand? Negative you have to connect it to the positive. then again another negative is connected to, so we can connect multiple cells like that. Here how many cells I have connected? I have connected 2 cells. Okay, if they give 3 cells, I will just connect like this, one more, minus, plus. And always remember, whenever we are connecting, simple electric circuit, whenever we are drawing, so we have to always, suppose you just have taken, see, one cell battery, this is one switch, okay, this is one bulb, and this is being here, and where to connect ammeter is being connected in series connection, and here wherever you can connect ammeter, no problem. So here I am connecting, means I will put A. Okay, so all these are wires. So here minus, because here minus and here minus should be connected to the minus, and the plus should be connected to the plus. And here you are using, means this is voltmeter connected in parallel connection. Okay, this is being connected in a parallel connection, and this is called plus, because plus should be connected to the plus side and minus should be connected to the minus side. This is a simple circuit diagram, consists of a cell, switch, ammeter, voltmeter, and a bulb. Okay, you can add so many components if you want, and you can add multiple cells also, means see, negative terminal should be connected to the positive terminal, then again the negative terminal, like this. So 2 cells. So did you understand? Yes, I hope you practice all this and note down each and every questions, so they are very repeated in the exams, and also they are very helpful for you in the upcoming exams. Okay, so this is about electricity and potential difference, and we'll see you. And please like, share and subscribe to my channel, and tell to your friends also, share as maximum as possible, so that I can reach for everyone. And if you want any notes or anything related to whichever the chapter that we are teaching, so it is being available in our Telegram channel, so that is being provided in the description box. Please share, subscribe and like.